Hello students, today you'll be taking notes on representations of functions and function rules from 6.2. When I say please write this down in your notebook, that's a chance for you to pause the video and then write down what I asked you to, or complete the problem and then resume the video to move forward. Let's begin. On our agenda today, you'll turn in homework number 41. You'll write the definition of a function rule, as well as writing function rules and making graphs. You have no homework tonight. Our targets are as follows. Write a function rule from words, mapping diagram, table, and represent one as a graph. Our key idea today is the definition of a function rule. Write this down, please. So you can pause the video if you like. Write down the definition of a function rule is an equation that describes the relationship between inputs and outputs. A function rule is an equation. Write that down. In this lesson, your function rules are all going to be linear, so slope-intercept form is the form that they will take. All right, so now let's practice writing function rules from some words. So here we go, part A. Try and write a function rule from the statement, the output is 5 less than the input. Pause the video and try and write it. Okay, using some of those buzzwords like 5 less, output and input, you can write an equation that looks like that. Y equals x minus 5. Move on to part B. Write an equation for the output is the square of the input. Square means power of 2. How'd you do? Did you get y equals x squared? All right, try one more. What is the value of y equals 2x plus 5 when x equals 3? So you're plugging in 3 for x. Pause the video, try it yourself, write it down. All right, so y equals 11 for part C. Okay, on this slide, you're going to copy down both the mapping diagram and the table into your notebooks. Then you're going to try and come up with the pattern so you can write a function rule, also known as an equation. And remember, they're in slope-intercept form, so be on the lookout for that slope. Let's try the mapping diagram first. From a mapping diagram, you could find the slope. You can also see the y-intercept, similar to a table. So your slope is found by finding the difference in the y value divided by the difference in the x value. This means change in y over change in x. So your slope so far is 1, or 1 times x. Your y-intercept is when x is 0, it's the output value of positive 2. So your equation is y equals x plus 2, or y equals 1x plus 2. Now pause this video and try and find the slope and y-intercept from the table. So far, we found that the slope, or change in y over change in x, is also 1 over 1 in this table. So we know m equals 1 over 1 for number 5. But I don't see the y-intercept because I don't see x equals 0 and what the y value is. Well, you could do one of two things. You could work your pattern backwards and identify your y value, or you can plug in what you know so far in for y equals mx plus b. So let's plug in what we know. We know the slope is 1. And here in the table, I've circled an x value and a y value. So I'm going to put that in for x and y. So I'll put a 1 in place of x. I don't know what b is, and I know y is 8. Simply solve for b. So 8 equals 1 plus b. So b equals 7. So your equation for the table is y equals 1x plus 7. Okay, so just like in chapter 4, when we were asked to graph linear equations, we're doing the same thing here. Instead of the word x or letter x, we're using the word inputs. So here on the right, you'll see the inputs or the x values to plug into this equation right here. So what you can do is show your work on the left side and then plot your points on the graph. We'll do one together, and then you'll do the next 3 on your own. So pause the video after the first example, and then do the next 3 on your own, and then plot the points. Okay, so we're going to take -1, and we'll plug that into the equation for x. So y equals -2 times -1 plus 1, which equals +2 plus 1, which equals 3. So y equals 3 when x is -1. So that's the coordinate. -1, comma 3, and you can plot that right now on your graph, right there. All right, now take 0 and plug it in Take 1 and plug it in, and take 2 and plug it in, and we'll see what you end up with. Pause the video and record them in your notebooks right now. All right, how did you do? Check out the work and check out the points on the graph. Congratulations, you graphed a function using 4 specific inputs. In this example, you get to pick the inputs you want to plug in. In the last example, you were told what inputs. This time, you choose. Choose numbers wisely, knowing you're dealing with a fraction of 3 over 2 is your slope, where you're going to need to be multiplying by 3 but then dividing by 2. So pick x values that easily are divisible by 2 as a hint. All right, get started by showing your work on the left side, then plot your points on the right. Pause the video and then resume when you're ready to reveal the solution. All right, check it out. How did you do? Plugging in -2, 0, and 2, those are the numbers I chose. You might have chosen different numbers, but our graphs should be the same. Okay, here's a problem you'll be asked to set up and solve. So this one's about a sale. A furniture store is having a sale where everything is 40% off. Your job is to write a function that represents the amount of discount on an item with a regular price of P. Then graph the function using those inputs, and finally answer part C regarding a bookshelf that you bought. Pause the video, and let's take a look at the setup. Okay, we'll first start with the function rule or equation. The discount you're going to receive will be the equivalent of 60% of the original price. When you take 40% off of something, that means you start at 100% of its value and you subtract 40%. And now you're paying 60% of the original price of that item. That's how we're multiplying 0.6 times the original price to figure out our discount. Now, another way of looking at this problem is understanding you want to know how much money you're actually saving. If you want to know how much you're saving, understand your discount can also mean what is 40% of the original price. So if you thought of this equation right here, this would tell you how much money you're going to save. This equation over here really refers to what is your sale price. That's what D would represent here. That's your price you're paying at the register. All right, for part B, I've made a table where we entered in 100 into our original equation for P and solved for D each time, our discounted sale price. So for a $100 item, it's now on sale for only $60. For a $200 item, plugging in for P, you have a new sale price of $120. And over here, we've graphed this situation using P as the X values and D as the Y values on our coordinate plane. Finally, in part C, you buy a bookshelf that has a regular price of $85. So what is the sale price? We'll simply plug 85 into our equation for P, and we'll calculate 0.6 times 85. Go ahead and do that and check your solution with me. Pause the video and write it down. All right, I got a for sale price down here in the right corner of $51 for that bookshelf. Okay, congratulations, you made it to the next step slide. So ask yourself, can I write a function rule from words, a mapping diagram, and a table? Really, can I write a slope-intercept equation from those representations? And can you write it with a graph? You have no homework, but you do need to upload your class notes to the Padlet, please. So please do so, and you'll find that Padlet linked on your Schoology main folder page or in the chat on Zoom. Have a great day. Thank you.